Welcome back. This week we're going to take a look at copper, bronze, and brass. And we're looking at chapter 18. Now, as you can see here, the final exam will be on May 6th, and I'll send that to you, and it's up to you to get back to me before the last day, which is the 9th. So next week is our last chapter, and that's on the 29th. So we're going to have a PowerPoint on magnesium, zinc, and specialty metals. So let's take a look here today and go through our PowerPoint. All right, chapter 18, copper, bronze, and brass. First of all, describe the desirable properties of copper and its alloys. Second, explain how copper is refined. We're going to see that. I'll describe it briefly, and then I'll assign a video for you guys to watch and give me some feedback on. And then we're going to describe the favorable properties of bronze and brass and explain the effects of work hardening, precipitation hardening of copper and its alloys. Again, there's some differences compared to steel and aluminum that we've looked at, but kind of the same concepts. So let's begin. First of all, copper, the history of it. The first metal lumps of pure copper were found in the Euphrates Valley in Iraq, of all places. And basically, it is one of the metals that actually comes out of the ground looking like what you see there. And it's said that people, centuries ago would find this, and then they learned that it was malleable. They could pound it into different types of tools and things like that. Well, it's not very good. It can't really keep a sharp edge very well, so it's not the best for any sort of weaponry. But for jewelry and for tools and things like that, it's very useful. Okay, so they did use it for spearheads, not for swords or anything like that, usually, and ornaments. Okay, now how it's made. I have a video that I'm going to put a link on in the email that I'm sending this to you and posting it on D2L as well. But as you can see here, here's basically, it's really kind of an interesting way that they process this. They take the ore and basically grind it up, as you can see there, and then it goes through this long extended process. And again, I'm not going to waste your time going through this on this little slide, whereas the video does a much better job of talking about how it's processed. Now, the copper alloy designations, I will not test you on this, okay, but it is important to note. Actually, I take that back. There is actually a final exam question, and it's like a true and false or something like that. And notice how the copper number has C in front of it, and that is to reference copper. So if you see something on the test where I show a copper designation is C, and only C, that's true, or that's the one you want, versus I can't remember how I do it on the final, but you'll find out. But anyhow, again, they don't really coincide with aluminum or with or steel designations, so just be aware. Don't expect to see that, because I always use the 5000 series, and you can see the 5000 series here is phosphor bronze, so copper tin alloys, and then the 53 and 5400 series is copper tin lead alloys. And if you remember the 5000 series, for example, of steel has chromium in it. So again, they don't align, so just be aware of that. Okay, some common copper alloys. The two most common are brass and bronze. And I have a lot of students who get these two confused, or they get them reversed, because there is a question or two on the final about these. So bronze is copper and tin. Brass is copper and zinc. And that's the confusion. I have students, because I have a question where basically I ask you one or the other, and usually and one of the answers is, the opposite, copper and tin or copper and zinc. And so just remember that bronze, copper and tin, brass, copper and zinc. So copper and tin is the first metal alloy discovered. It's less than 25% tin added to the copper as an alloying element. brass, on the other hand, copper and zinc, and that predates 600 BC. Great thing about brass is it resists seawater corrosion, and it has between 5 and 30% zinc. So when you're talking about iron and steel, remember the element that we have there is carbon, and we don't see usually much above 2% when it comes to steels, unless you're getting some exotic stuff. But look at this. I mean, like, you're talking 25 to 30% in some cases of zinc or tin added to make these. So significant amount to copper. All right, so changing the properties of copper. Alloying, adding elements to increase strength. Again, lead adds machinability. Zinc, seawater corrosion resistance. And again, this class was mostly to just give you an overview of this. We're not going to go into the big details of these, but just want you to have a basic understanding of them. Okay, and then cold working, just like we saw with aluminum, helps improve strength. And there's, in your book on page 265, again, it gives a radiator as an example of all things for cold working. And we've talked about that. And I believe in the video it might discuss that as well. And then there's precipitation hardening. Okay, 1.9% beryllium and 0.20% cobalt would make C17200. All right. And that was a kind of a quick chapter, but again, when you watch the video, it's going to give you a much better overview. I'm not one to typically want to lecture too long, although when we have the classroom discussions, we have a lot of fun, as you guys might remember. We talk about things like, for example, copper's been in the news a lot lately because of its ability to be antimicrobial, especially with the current situation when we're talking COVID-19. Typically, the reason for that is that the copper atom has a valence electron on the outer perimeter. And basically, from what my understanding is that extra valence electron, which actually gives it good conductivity electrically too, because the ions can travel over that. But in this case, it actually bombards, that extra valence electron bombards DNA that, for example, of a, let's say a virus lands on copper alloy and it just sits there. Eventually, the electrons kind of chew it up because it's, imagine like a paper shredder and you put paper in it and how it just kind of grinds it up. And from what I'm reading, that's essentially what copper does with that extra electron. So pretty interesting stuff. What they're saying, though, it could last up to 24 hours. The virus, this particular virus, could last up to 24 hours on a sheet of copper, and that's highly unusual. I read an article from Metallurgy Ch, actually it was in the Wall Street Journal, and said that typically microbes that land on it get eaten up within minutes. So this COVID-19 is a pretty strong entity. But when you compare that to, it takes 3 times as long on like steel. They said like stainless steel, it'll live almost 3 days. So copper definitely has its benefits. So if any of you ever have the chance to get a nice copper sink, like if you're remodeling your house, go for it. They're expensive as all heck, but they look really sharp, and they're also antimicrobial. Okay, so what we're looking at for next week is read chapters 19 on magnesium, zinc, and tin and specialty metals. Complete questions 1 through 10, 19, 20, and on page 284. And just a reminder, on the 6th, I'll send off your final exam to you, and it's open book, open note, and then email it back to me. What I'm going to do is I'm just going to have you put in I'll send a little text file where you could just type in, like, number 1 is A, number 2 is B, number 3 is this. And then there's some of them you're going to have to type in as well. But I believe there's about 40 questions on it. And also, next week I'll assign the video for the katana. So you'll get to watch that, and there's a couple extra credit questions on that. And you're comparing the katana, which is a Japanese samurai sword, and its metallurgical properties to the metallurgical properties of the Umfbert, the Viking sword that we saw the video on. And so if you could mention a couple different things about the two and how they vary. Looking for a couple specific ones actually that are pretty big. But anyhow, whatever you have on that, you'll be able to give me some extra credit, or you'll be able to get some extra credit for that. Okay, and the last day is the 9th. Everything needs to be turned in before the end of class that day. We won't be coming back, of course, this semester, but sorry it had to turn out this way to everyone in the class. You guys, you're an exceptional class. We were having a lot of fun, I felt, up until this COVID-19 outbreak. So sadly, didn't get to talk to many of you as much as I would have liked to, and love to have gotten to know each one of you a little bit more through discussions in class and such. But good luck to you, and be safe.